Hello guys, welcome to today's video. Today we'll be discussing about the brown ring test for nitrite ion. So what is the brown ring test? Basically in this test we take a solution with nitrite ion like NO2 minus solution and we slowly add it to a freshly prepared FeSO4 solution. Now one thing to note in this is that this is freshly prepared. Now, what is the significance of freshly prepared? So, as you guys must know, this is in +2 oxidation, so Fe2 plus. This is prone to aerial oxidation and readily converts to Fe3 plus, which does not give the brown ring test. Brown ring test. So hence we want a freshly prepared FeSO4 solution so that it does not oxidize into Fe3 plus. So I think this point's clear. Okay, so I'll just erase this. Yeah, so this solution slowly added. Now it's slowly added because brown ring test, it's like a very gentle process. Even if you shake the test tube a bit or like warm the test tube a bit, this test won't be there. It won't be like, you won't see the appropriate results you want. So you'll have to perform this very slowly and steadily, of course. So yeah, so freshly prepared FeSO4 solution, this is slowly added and now it is acidified with either with like we can take dilute ACOH or dilute H2SO4. Now these two are like very specific and these showed the desired result with the reaction, so we are talking about this right now. Although I'll just tell you one example why concentrated H2SO4 can't be used. So why this can't be used? So this is because concentrated H2SO4 produces brown fumes, intense brown fumes with NO2 minus solution. This produces intense brown fumes with NO2 minus solution, and after this it's not showing the ring, so no ring can be observed. Right, so that is why we don't use concentrated H2SO4. How was this determined? This was determined in the lab. There's no like theoretical reason for this. It's purely experimental. Okay, so now that we have talked about it, now the reason it has to be acidified will be clear when I explain the reactions to you. So okay, now some of you might be wondering what the FeSO4 solution is. FeSO4 solution is not actually FeSO4. Like, for this case, we are not talking about actual FeSO4. It is the reaction, it is the product form on reaction between FeSO4 and water. It is actually a complex formed on the reaction of FeSO4 and water. So let's find out what the complex is. The complex would be Fe H2O 6 2 plus. Right, this is the complex formed on reaction with FeSO4 and H2O. This complex would be formed. Now see, for this complex to give the brown ring test, we require NO. In order for this compound to give the brown ring test, we require NO. How can NO be formed? NO can be formed on the decomposition of HNO2. If we decompose HNO2, we get HNO3 plus NO plus water. So we can get NO on decomposition of HNO2. Now how will we get HNO2? HNO2 can be NO2 minus plus H plus. So see, this H plus is released from a substance, and that substance is called an acid. An acid is called a substance that releases H plus in the aqueous solution. So this H plus would be released by an acid. So now I think this point is clear of why we need to acidify the solution. Okay, so I'll just erase this real quick and write down the proper reaction. So this is the FeSO4 solution. This complex would be formed. Okay, so our first reaction would be H plus from an acid reacts with NO2 minus to form HNO2. Now this HNO2 will decompose, or it won't even decompose, it will just change. So like as the solution's kept, it will change to HNO3. So I'll not say it's decomposing. HNO3 plus NO plus H2O. So now if I balance this reaction real quick, this will be a just give me a second, guys. Yeah, this will be 3 and then 0 2. Okay, and this will be 2 if I'm not wrong. Now let me just check whether it's balanced. Yes, it's balanced. Okay, so let's continue. So now this NO released, right? So this will be released. This NO released will react with this complex FeH2O6. FeH2O6 2 plus NO will give us a complex FeH2O5 NO 2 plus H2O. Now you look at this complex, right? So this is the complex giving the brown ring. So the complex forming the brown ring is FeH2O 5NO2 plus. So this is a complex between FeH2O and NO. This question can be asked. So it's a complex between FeH2O and NO. So now see, this complex is unstable. Which I previously said that shaking or warming, if you shake and warm this will become unstable, and hence NO will be liberated very easily. So we cannot shake or warm anything, and we need to add the FeSO4 the nitrite solution slowly to the FeSO4 solution, and the FeSO4 solution should be freshly prepared. So what we learned in today's video was brown ring test for nitrate ion. First we take a nitrate ion, slowly pour it in the freshly prepared FeSO4 solution, acidify it with dilute ACOH and H2SO4. We cannot use concentrated H2SO4 because of the intense brown fumes formed. Now FeSO4 reacts with H2SO4 to form this particular complex, and the hydrogen ion released from an acid reacts with the nitrate ion to form HNO2. Like when it's kept, basically converts to this, I won't say decompose, gives off NO. This NO reacts with the complex formed here in order to form a new complex which gives our brown ring. This is very unstable, so we cannot shake or warm it, or else the NO would be released easily. So thanks for watching today's video. The next video will be about the brown ring test for nitrate ion. Yes, the brown ring test can be carried out for both nitrite and nitrate. So thanks for watching and stay tuned.